So we want to revisit the definition of area in terms of how we found the area under a curve, okay, by dividing it up into rectangles. And in this section, what we particularly want to do is understand like what kind of result do we get if we did a left-hand limit. Right, so the left-hand sum. So we take the left-hand and we get the y values on the left end of it, and we add up these rectangles. Okay, versus right, versus trapezoid, versus midpoint. Okay, so that's the left end. If we do the right end, right, we would get this one, the blue here. You can clearly see, okay, when it's concaving down like this, and this concavity is going to be a really important theme, right? The left hand is an underestimation, then this is an overestimation. And let's now visualize midpoint. So that's the midpoint. Take the midpoint. So midpoint is nice because a little bit of it is underestimation and a little bit of it is overestimation, right? So we're grabbing that, but we're not grabbing that part. But it looks like they're, it's almost canceling each other out, right? So in general, midpoint is going to give us a pretty good, in fact, much better estimation than left-hand sum or right-hand sum. Okay, so just being able to visualize and have a sense of what kind of estimation we get is really important in this section. Okay. And then lastly is trapezoid. So let me see if I can grab a different color, gray. And trapezoid is you grab the endpoints. Okay, so the y values of here and here. Okay. Okay, so I just zoomed in a little bit. And you can see because it's concaving down, it's much better, again, it's much better than the left-hand sum or right-hand sum, but it's still a little bit of an underestimation. So we're talking about this right here, this gray part, under the line, right? We're missing this portion right here. We're not capturing that. As it flattens out, you can see we're missing out on less and less, right? When it's not flat, when this rate of change is really fast, we're actually missing out more. Okay, so let's say we just extend this to the end here. Okay, let's call this A, the ending B, right? Or we can also call AX0 and this XN. So this is X1, X2, X3, X4, right? And this is Xn minus 1. So left hand sum is delta X, right? Over delta X is referring to the width of this. So delta X is clearly B minus A divided by n intervals. So it's delta X times by, right, base times by height, but for the left-hand sum, it's going to be X0, X1, next one's X1, X2, and so on, right? All the way to the last one is f at x minus 1. Okay. And the right hand is going to be, doesn't start at x0, but we take the first height at x1. Okay. And it goes all the way until xn this time. One more than this. Okay, so that should be pretty easy for you to write out. What about the midpoint? Okay, so midpoint, we're gonna say it's x1 bar, and the bar represents the midpoint between x0 and x1. x1 is gonna be x2 bar all the way until xn bar, where xi bar represents xi minus 1 plus xi divided by 2. Okay, it's the midpoint between this one and the previous x value. Okay, that's the midpoint. And what about the trapezoid if we were to write it? So trapezoid this is the height of the trapezoid, and you got to add up these two parallel sides. So it's the first one is f at x0, right, plus f at x1 times by delta x and divide by 2. Okay, next one is going to be f at x1, so add up this plus this and divide by 2 and times by delta x, okay, all the way until xn minus 1 f at x1 over 2. Okay, so if you factor out half, so you get delta x over 2. Okay, f at x0 and xn here, xn, we get to only add up one of each. But every term after that, x1 gets repeated twice, x2 will get repeated twice, this one will get repeated twice. Every single term in between will get added twice. All the way until, okay. So those are the estimation, left-hand estimation, right-hand estimation, midpoint, and trapezoid. Okay, this is all something that you should already know. Now let's use this to do an estimation of sum, and afterwards we want to focus on like how much error each one causes, and especially relative to each other. So which one has the most error, which one is an over or an underestimation, and so on.